Hello guys, today we will discuss stars and bars techniques, sometimes known as dots and dividers. In this problem, we are given n balls, n indistinguishable balls, and k distinguishable beans, and we want to distribute these n balls into these k beans. This is the equivalent of computing how many ways can we choose k non-negative integers, x1 plus x2 plus xk equals to n. Imagine that we are given these n balls and we want to draw lines, separator lines between these balls, which this one assigns number of bolts in the first bin, this one assigns number of bolts in the second bin, and so on. In total, we will make up k minus 1 divider lines because they will give us exactly k segments from kx1 to xk. And to compute this value, we can just convert these divider lines into balls once again, and imagine that we are given in total n plus k minus 1 balls. And out of these n plus k minus 1 balls, we just need to choose k minus 1 balls, which will be converted into the delimiters, divider lines. And this can be done in n plus k minus 1, choose k minus 1 ways, because in total we have n plus k minus 1 possible choices, and k minus 1 of them must be chosen, which will be exactly n plus k minus 1 factorial divided by k minus 1 factorial times n minus k factorial. Here we can see several different applications of stars and bars. Sometimes instead of non-negative numbers, we may have positive values. For example, if we have x1 plus x2 plus xk equals to n, but each of xi is greater than 0. In this case, we can just make up yi equals to xi minus 1, and yi's will be non-negative numbers, greater or equal to zeros. And yi, sum of the yi equals sum of the xi minus k, because each value of yi equals xi minus 1. And clearly this will be equivalent of n minus k. And if we apply the stars and bars technique for the same numbers, like y1 plus y2 plus yk equals to n minus k, our formula can be rewritten as n minus 1 choose k minus 1. Because in our case, instead of n, we have to choose uh, n minus k. And once we take n minus k plus k minus 1, we will get exactly n minus 1. Sometimes we may have additional restrictions. For example, if x1 is greater than 2 or greater or equal to 2, and x3 may be greater or equal to 10, and so on. This is almost same idea. We can just take y1 equals x1 minus 2 to make this non-negative integer, and similarly y3 take x3 minus 10, and do the same process for every restriction. One a bit advanced topic is if we have less or equality case. If we have x1 plus x2 plus xk less or equal to n. In this case, we cannot apply our formula directly. We may have we may consider several cases if this value equals to n minus 1, n minus 2, and so on. And after this, we will need Pascal's triangle to compute the total sum, but this is a bit routine casework. And to avoid this, there is one approach which takes new element xk plus 1 equals n minus x1 minus x2 xk. And in this case, we will get x1 plus x2 plus xk plus xk plus 1 equals to n. And if we apply our formula once again, we'll get n plus k plus 1 minus 1 choose k plus 1 minus 1, which will be rewritten as n plus k choose k. This was all I wanted to discuss about stars and bars, and now see several applications. For example, if you want to find sum of 10 numbers, x1 plus x2 plus x10, less or equal to 2025, but greater or equal to 2000. This can be solved as x1 plus x2 plus x10, less or equal to 2025, minus cases when this sum was also less or equal to 1998, no, 1999. So the first one can be computed as 2035 divided, choose 10, and bottom one will be 2009, choose 10. And if we consider their subtraction, we will get the answer. This was all I wanted to discuss for today. If you have any questions, please write in the comments.